Hi everybody. So today I wanted to talk about the HM6264 SRAM IC. So you can see the chip is right there. And there's a few extra chips on this board. So this over here is a NAND gate 7400. And then this is just a resistor array. And then this is the 74HC245 octal bus. It's just the buffer. So the actual HM6264 has this pin out. So it has addresses 0 through 12, and those are the green wires in my circuit. It has these I/O pins, which are the orange wires in my circuit, and the red wires. And it has chip select 2 and chip select 1. Chip select 1 you would want to put low since it has the bar over it, and chip select 2 you would want to put high, so you could select the chip. It also has write enable and output enable. Now, those are also active low, and I'll talk about those in a second. And it has obviously ground and power, pins 14 and 28, ground and VCC, and pin 1 is just not connected, and C. So, in one of my last videos when I was talking about the 7489, I talked about how the HM6264 is a little bit different because the inputs and outputs aren't separated. As you can see, the inputs and outputs are actually the same pins. So that can get kind of irritating if you're just trying to program the chip manually like this, which is what I'm trying to do, because you would have to basically, when you were writing to the chip, you would have to disable the outputs, and you'd have to, put your input pins into these pins. And then when you were ready to go into read mode, you'd have to take the input pins back out to be able to read from the chip. So that's not really something that you're going to want to be doing all the time. So I built kind of a workaround. So the way that it works is basically what you want is that when write enable is low and you're in write mode, you want the output enable to be high. So the outputs are off and the inputs are on, and you could just put whatever inputs you want. And the inputs here are these white wires. And then whenever you put write enable high to go into read mode, so you disable the write mode, you want to bring output enable low, which would enable the output and turn the inputs off. So the circuit that you would build to do that is what this NAND gate is doing. Now this NAND gate here, I'm just using it as an inverter. I didn't have any 7404 inverters handy, and I didn't think it would be very practical to use one because you only need 2 inverters for this. So I decided to just use a 7400. And in my last video I talked about how if you tie the 2 inputs of a NAND gate together, you turn them into an inverter. So that's what I did. So you can see that on this top one, these are the 2 inputs. So the write enable comes in here. It's actually one of the inputs. And there's this wire over here that's connected to the write enable, and this is just the wire for write enable, this blue wire. But the inverted output of whatever you put on here, so right now it's high, this is going to be low, this little red wire going to this input. And then on this input down here, which is basically the inverted of this, you put that to the output enable pin, which is pin 22 on the HM6264. So the reason that you do that is, as you can see, anytime write enable is low, output enable is high. When write enable is high, output enable is low. And that just makes pretty logical sense. So that's why that part is there. And then this blue wire over here, that's basically like the uninverted output. It's basically the same as, would it be the same? Let me think about this for a second. I think that it's the same as this part right here. So theoretically, you can do that. Yeah, that actually works. So what you can do actually is not even use this bottom NAND gate at all. I made a little discovery in my own video. So you don't even need this part. We could basically just use one inverter for the whole thing. So I could take this whole bottom part out. See if I could fish this chip out with my finger. Probably not. But I need this to go to this inverted output over here. That's funny. That's honestly pretty funny. Now, I hope you guys could see why I actually was able to just discard this bottom one, because the only one that we need to invert is the write enable and output enable, and this basically corresponds to the write enable. So whenever I bring this low, it'll activate this latch or turn the outputs of it on, so that we can input to the HM6264, and I could change these when I'm not in write mode freely. As you can see, it's not changing anything on the outputs right now when I do this. And I could write to the chip right now. I could bring the write low, and there you go. So that's actually a good thing that I just discovered. So you really only need one inverter, which is pretty cool. And you guys might be wondering what all of these 820 ohm resistors are. They're just pull downs for all of the inputs, such as these address pins or the data pins or the those enable pins and write pins. All of them have 820 ohm or 1K pull downs. But yeah, that's basically how you would actually use the HM6264. And I'll show you guys again on my 6502. I don't know if I talked about it at all, but I'll show you guys in a little bit more detail how that's connected. So let me turn on the light here. So on the HM6264, there's an SRAM chip up there, but there's also one right here, which is the HM6264. And you could see that I just connected all of the address pins to the whole address bus and the data pins to the data bus. But I needed some extra address decode logic with the NAND gate and an OR gate to be able to address this second SRAM IC. But yeah, that's basically all of the practical uses of it and the hands-on uses of this IC. If you guys have any questions, or if you would like me to make a part 2 about this chip, let me know in the comments. But other than that, thank you so much guys for watching, and I'll see you guys in the next video.